Hey, I'm Crumbs, a tutor from Inflection University, and today's calculus topic is one of my favorites since we don't have to do any math. We're going to try to determine characteristics of the graph of a function f without ever drawing it. Instead, for our 5 examples today, we're going to use characteristics of this given f prime graph to get an idea of what f looks like using various calculus rules. Let's briefly go over those rules. First, f is increasing when f prime is positive, and similarly, f is decreasing when f prime is negative. F has a local max or relative max when f prime goes from positive to negative, and f has a local minimum when f prime goes from negative to positive. Next, f is concave up when f double prime is positive, and concave down when f double prime is negative. But since we are given a graph of f prime, we should use the concavity rules that contain f prime. So we will be using the rule that f is concave up when f prime is increasing, and concave down when f prime is decreasing. In the same vein, there is a rule that says f has an inflection point where f double prime changes signs. But because we are given a graph of f prime, we are going to use the rule that says f has an inflection point where f prime goes from increasing to decreasing, or decreasing to increasing. Now that we have all the rules, let's discuss the trickiest nuance of these questions. For instance, while our question might be where f is increasing or decreasing, since we are given the graph of f prime, we are going to instead focus on where f prime is positive or negative. So, for every example in this video, we always care more about f prime than f, even if the questions are about f, since we are trying to utilize our f prime graph as much as possible. This will make more sense as we cover our examples, so let's get started. So, for our first example, using our given graph of f prime, we are going to try to determine where our graph of f is increasing. If you're unfamiliar with this type of question, it's a bit counterintuitive. The question asks where f is increasing, but we won't actually be looking for any increasing portion of our given graph. Instead, because f is increasing when f prime is positive, while our question is about f and where its graph is increasing, we are going to focus on the latter part of this rule, since we are given a graph of f prime. So, let's try to see where this given graph of f prime is positive, meaning above the x-axis. It looks like our f prime graph is positive on the interval -3 to -2, and f prime is also positive from x equals -1/2 to 3. So, f is increasing on these two intervals since f prime is positive there. So, as long as you memorize our increasing rule and focus on the f prime portion of the rule, you'll be able to master these f prime graph questions. Now, using our f prime graph again, we're going to try to determine where the graph of f is concave down. There is a rule that states f is concave down when f double prime is negative, but because we are given an f prime graph, we will instead use another rule that states f is concave down when f prime is decreasing. We will thus look for portions of the graph of f prime where we are going downhill as we go from left to right. Focusing on our f prime graph, it looks like f prime decreases from -3 to -1, and also f prime decreases from 1 to 3. So f is concave down from -3 to -1 and 1 to 3. This time we did focus on where we were decreasing on the graph of f prime, because that happens to be the requirement for a concave down function. Now we are going to use our f prime graph to find where f obtains a local or relative maximum. So unlike our previous example, our answers won't be intervals, but instead specific x values. This time, our rule states that f has a local max where f prime goes from positive to negative. Again, we won't look for x values that look like maxes on f prime's graph because we don't care about the local maxes of f prime. Instead, let's find where f prime goes from positive to negative, since that's where the graph of f, which we won't ever draw, will have a local maximum. It looks like as we move from left to right, f prime's graph crosses the x-axis from the positive direction to the negative direction at x equals -2. So f has a local maximum at x equals -2. Again, you should be good to go with these types of questions if you focus on the f prime portion of the rule rather than the f portion. The final member of the quartet of f prime graph questions is to find where f has an inflection point. Like with concavity, f has 2 rules for an inflection point. The first says that f has an inflection point when f double prime changes signs, but we use that rule when we can take derivatives, and it would be annoying to take a derivative of a graph. Instead, since we are given a graph of f prime, we are going to use the rule that says that f has an inflection point where f prime goes from increasing to decreasing or decreasing to increasing. It looks like f prime goes from decreasing to increasing at x equals -1, and f prime goes from increasing to decreasing at x equals 1. Thus, f has an inflection point at x equals -1 and 1. Now, you can solve all of the main questions that utilize a graph of f prime. Frequently, calculus assessments like the AP exam combine our first two examples into one question. So, for our last example, we want to know where f is simultaneously decreasing and concave down. Well, f is decreasing when f prime is negative, and f is concave down when f prime is decreasing. Since f is decreasing when f prime is negative, let's focus only on the negative portion of our graph. And on this portion only, we want to see where our f prime graph is decreasing, since that's when f is concave down. So, the interval where f is simultaneously underneath the x-axis and going down is from -2 to -1. So, f is both decreasing and concave down from x equals -2 to -1. Hopefully now you can determine various characteristics of a graph of the function f from a given graph of its derivative. If you want videos on questions about increasing, concavity, local extrema, and inflection points where you actually take derivatives, be sure to subscribe and check out those videos on our channel. Thanks for watching.